Okay, so hi, I would like to present the topic of capacitor and its significance of the industry. Okay, so my group members is Muhammad Dana Ali bin Abdullah, Anis Sufia binti Sin Shukri, and Nurul Izanti binti Razuran. So for the introduction, a capacitor is like an electronic storage tank that can hold and release electrical energy. It has two metal plates and separate by a special material, and when you connect to a power source, it stores a charge. Later, it can release that stored energy back into the circuit when needed. Capacitors are used in electronics for various purposes, like stabilizing voltage and controlling the flow of electricity. Okay, so for the objective, to achieve learning objective, define capacitance along with the unit and measurement of the symbol. To determine capacitance of a parallel plate capacitor, to investigate the capacitor's energy storage mechanism, to fully understand a capacitor's characteristic, and to figure out how capacitors are used in industries. Okay, so this is a difference of capacitor and capacitance. So for the capacitor, stored electric charge and electrical energy consists of two conducting objects, that is plates and sheets, commonly used in electronic circuit and have application in many areas of science and technology. A simple capacitor consists of two parallel metal plates separated by a small distance. For the capacitance is expressed as the ratio of the electric charge on each conductor to the potential difference, like voltage, between them. The capacitance value of capacitor is measured in farads. A farad is a large quantity of capacitance. Most household electrical devices include capacitors that produce only a fraction of a farad, when 1,000 of farad for microfarad, or as small as a picofarad, like a trillionth. Okay, so next is the types of capacitors. The first one is firm capacitor. It is used in variety of electrical circuits such as coupling, decoupling, and signal processing. Wide range of applications can also be due to their high voltage handling capabilities. So the second one is ceramic capacitor. It is the ideal for high frequency applications due to their low inductance, fixed capacitance, and no polarity. Next is electrostatic capacitor, ideal for use in DC power supply circuits due to their compact and high capacitance, widely used in power supplies and filtering device. Next is paper capacitor. Capacitance range of 0.01 to 2.00 microfarads and voltage range of 2000 volt. So this capacitor absorbs moisture from the air, lowering the electronics insulating resistance. So the last one is uh, tantalum capacitors. The capacitance values ranging from 1 nanofarad all the way to 72 microfarad, widely used in a various electronic device, including the speakers and the cell pin. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Bin Alif, and on my part I will be explaining about parallel plate capacitor. So as you can see, the parallel plate capacitor that are connected to a battery, the picture shows that the charge flow from the positive terminal to the negative terminal. And then for the next one, consider a capacitor with two parallel plates of each cross-sectional area A and separated by a distance D. So as you can see, the area A and area D is placed on our left hand side and right hand side, and separated by the area D in the middle of the middle of the area. So the next is a explanation. When a capacitor is connected to a battery of potential different V, the electrons are transferred from one plate to the other plate by battery, so that one plate become negatively charged with a capacitor with a charge of negative Q, and the other plate positively charged with positive Q. The potential difference between the plate is equivalent to the battery terminal voltage. In general, the charge stored in the capacitor is proportional to the potential difference between the plates Q directly proportional to the V, so that it makes Q equal to CV. The unit SI for capacitor is farad with the symbol of uppercase F. The next one is the example question. So, a parallel plate capacitor is constructed with a circular plates of radius 8 cm. They are separated by a distance 2 mm. A. Calculate the capacitance of this capacitor. B. If a 12-volt battery is connected to the capacitor, what is the charge stored in any one of the plates? And then the value of permittivity is 8.85 times 10 to the power of negative 12. So for the solution, A, the capacitance of the capacitor C is equal to permittivity A over D, while A is pi r square, which is the circular area formula. And then C equal to 8.85 times 12 times 10 to the power of negative 12 times pi times 0.08 square over 0.002. And then C we get 1.779 times 10 to the power of negative 13 farad. B. Calculate the charge stored in any one of the plate. As the formula stated earlier, Q equal to C dot V. So Q is equal to 1.779 times 10 to the power of negative 13 times 12. And then we get Q is equal to 2.135 times 12 times 10 to the power of negative 12. C column. So that's all from me.
Hi, my name is Nurizati Natira Zuran. Today I would like to explain about its significance in the industries. For energy stored, capacitors play a vital role in stabilizing power supplies. They act as voltage reservoir, absorbing excess energy when voltage is high and releasing it when it's low, ensuring a consistent and smooth power output. Connected parallel to the load and they charge and discharge as needed. Capacitor also excel in providing quick bursts of energy for applications like camera flash and pulse generators. They discharge rapidly during high demand moments, supplying instant power, and recharge during lower demand period, showcasing their flexibility in adapting to changing electrical needs. These are the examples of energy stored. So, defibrillator and medical devices. In medical application, capacitors are essential components, particularly in devices like defibrillators. These devices utilize capacitors to store and release electrical energy in a controlled manner. During emergency situations, defibrillator deliver precious shock to the heart, and capacitors play a crucial role in generating the necessary electrical energy for these therapeutic interventions. The capacitor stores the energy and releases it rapidly when needed, contributing to the effective and regulated administration of shock to restore normal heart rhythm in critical medical situations. These are examples of defibrillator and medical device. For motor starter capacitor and run capacitor. Capacitor in electric motors serve as dual purpose. Start capacitor kickstart the motor by providing a surge of energy at the beginning and helping overcome inertia. They have a higher capacitance value and active temporarily disconnecting once the motor reaches a certain speed. On the other hand, run capacitor maintain a steady flow of power after startup, ensuring the motor operates consistently. They operate continuously and enhancing motor efficiency by optimizing power factor and reducing overall power consumption, especially in motors with continuous operation like those in air conditioner units or refrigerator system. This example for motor starter capacitor and run capacitor. For conclusion, in summary, capacitance is measured in Faraday, defines capacitor ability to store charge per voltage unit. We have learned to calculate capacitance for parallel plate and how it depends on physical charge. Understand energy stored U equal to frac 1 over 2 multiply C with V square. We acknowledge capacitor vital role, understanding into character and better understanding of their behavior in AC circuit. Capacitors are used in a variety of applications, from power correction to medical devices, and showing their importance in shaping varying electronic systems throughout the industries. Okay, thank you from me.